Okay, our aim for today is how do we prove the properties of a parallelogram? So let's first review what the definition of a parallelogram is. So a parallelogram is a quadrilateral, a four-sided figure with both pairs of opposite sides parallel. That is the definition of a parallelogram, and that's where the definition ends. But we discovered certain properties of a parallelogram. And what were those properties? Well, let's just review them. So, to review the properties of a parallelogram, number one, well, a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. That's the definition. But we also discovered when we were measuring the sides of a parallelogram with our rulers, we measured the sides and we noticed that both pairs of opposite sides were congruent. Okay, so not only is AD and AB, not only are they parallel to each other, they are also equal to each other. And we discovered that the horizontal lines, namely AB and DC, they were also congruent to each other. Another property we discovered was that both pairs of opposite angles were congruent. In other words, if you measured big angle D and big angle A, you will have noticed that they were congruent to each other. Similarly, if you measured big angle A and big angle C, those were also congruent to each other. That was another property that we discovered, which is a theorem. So remember, anything that is a theorem can be proven and must be proven, and we will prove. Another property that we discovered was that consecutive angles are supplementary. In other words, if you took angle D and angle C and you added them together, they would equal 180. Similarly, if you took angle A and you added that to angle D, they were equal to 180 degrees as well. What was another property we discovered? Well, this had to do with the diagonals. We said if you measured DE and BE, you will notice that this diagonal was being bisected by AC. It was being cut in half by AC. Similarly, we noticed that DB was also bisecting AC. In other words, DB was cutting AC in half, which meant that, we can use 4 hash marks here, AE and CE were congruent to each other. That was another property we discovered. We're going to focus our attention on this property, which is a theorem. In other words, we're going to prove that if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. We're not going to prove it by measuring. We're going to prove it mathematically with logic. So let's take a look at what the proof looks like. So given parallelogram ABCD, this means parallelogram, given parallelogram ABCD, prove that opposite sides are congruent. We know opposite sides are parallel, prove that opposite sides are also congruent. So let's talk about this first. Okay? And one of the things we're going to try to use is triangle congruence. In other words, we're going to try to show that triangle 1 and triangle 2 are congruent to each other. And if that's the case, then we know that corresponding parts are congruent to each other. So that means that AD, which belongs in triangle 1, is going to be congruent to CB because corresponding parts of congruent triangles are congruent. We will also show that CD, which is part of triangle 1, must be congruent to BA, also because corresponding parts of congruent triangles are congruent. In other words, what we're going to try to show is that this triangle here, this red triangle, is congruent to the second triangle, triangle 2. And if that's the case, then DA, notice how that corresponds to BC, which would mean that opposite sides are congruent. And that would also mean that CD, notice CD, that would mean that CD is also congruent to BA. They are corresponding sides. So our task is to prove that triangle 1 is congruent to triangle 2. And many proofs use triangle congruence in order to actually prove properties. So let's go from the beginning and we'll walk through this. So first statement, ABCD is a parallelogram. Well, what's the reason for that? Well, that's given to us. Right? What do we know? If ABCD is a parallelogram, what do I know? I know that both pairs of opposite sides are parallel. In other words, I know that BC and AD are parallel. I also know that AB and CD are parallel. So I'm going to say that. I know that AB, line segment AB, is parallel to line segment CD. And I also know that line segment BC is parallel to line segment AD. That is the definition of a parallelogram. Both pairs of opposite sides are parallel. Well, The moment you hear of parallel lines, you need to think of all the angles that are associated with parallel lines cut by the transversal. What transversal are we talking about? This one right here, AC. That is our transversal. That is cutting the parallel lines. So let's see which angles are congruent. So if line segment BC and AD are parallel, as we say right over here, and this is the transversal, that means that these two angles, angle 2 and angle 3, are congruent because they are alternate interior angles. And notice how they say that angle 2 is congruent to angle 3. And we also know that if these two lines, namely BA and CD, if they are parallel, because it is a parallelogram, well, that means that angle 1 is congruent to angle 4. Again, because alternate interior angles are congruent. If two parallel lines, BA and CD, are cut by transversal AC, that creates alternate interior angles 1 and 4 that are congruent. So that's why they say angle 1 is congruent to angle 4. And the reason for that is because alternate interior angles are congruent. Okay, well, that's nice because I now have two angles in one triangle that are congruent to two angles in another. But AA is not a proof of congruence. So what do I need? I don't have any other angles, and even if I did, AAA is not a proof of congruence. But what do I have? What do I know? I know that AC is equal to itself. Remember, I cannot use what I'm trying to prove in my proof. The only other side that exists now is AC. And I know that AC is congruent to itself. I like to say AC is equal to CA because, as you saw before, what we're doing is we're taking triangle 1 and we're rotating it around this point over here to get to triangle 2. So AC in triangle ACD is congruent to CA in triangle CBA. So then the reason for that is the reflexive property. So there I've got a side. So why are these two triangles, triangle ADC and CBA, congruent? Well, because of angle, side, angle. I've got these two angles, angle 2 and angle 4, angle 2 and angle 4, with the side in between, this side, side AC. I've got angle 1 and angle 3 with this side, the same side, AC, in between. Well, if that's the case, what do I know? I know, therefore, that line segment CD, this line right over here, is congruent to BA. In other words, I know that CD is congruent to BA. You can say AB is congruent to CD. The best thing is to state exactly what they're asking us to prove, namely that line segment AB is congruent to line segment CD. And what else do I know? I know that these two line segments, AD and say CB, they correspond to each other and they are equal as well. So line segment BC is congruent to line segment DA. The reason for that? Because corresponding parts of congruent triangles are congruent. Please make sure this is in your notes if you need to put your player on pause, and make sure every step is there.